Hello everyone. I'm Aya Hussein, a research associate with the University of New South Wales in Canberra. My talk will be about the role of transparency in human-swarm interaction. And let me start with a brief description of what swarm system is. A swarm is a group of individual robots, typically with limited processing capabilities. The local interactions between these robots can result in complex behaviors like flocking or area coverage. Swarm systems have three key advantages um, that can be summarized as their scalability, flexibility, and distributed nature. These advantages make swarm robotics have the potential to be used in different applications, including urban search and rescue, as well as monitoring and surveillance applications. So why is a human needed in swarm operations? As a matter of fact, the human element is necessary in swarm operations to make sure that swarm behaviors align with the objectives of the mission. Humans also can work in and adapt to highly complex and dynamic environments, hence enabling the success of swarm operations in such settings. However, there are several human factors that can impact the interaction between human and swarm. Of these factors, trust has drawn the attention of many researchers. Well-calibrated trust was shown to be necessary for the success of human-machine interactions. Both overtrust and distrust should be avoided. Overtrust causes over-reliance on automation, which means that a human would accept its automation actions without double-checking them, although some of these actions could be erroneous. In contrast, distrust leads to rejecting machine's aid even when the machine is reliable. Obviously, both situations of distrust and overtrust should be avoided as they cause um, decreased efficiency and might even result in uh, um, serious consequences. Our work, our work has been concerned with whether and how transparency can affect the quality of human-swarm interactions. Literature in the broader area of human-robot interaction and human-machine interaction found that transparency can be used for better to improve the interaction between a human and the machine. This is because by offering a human um, um, a way to understand more about the internal working of the machine and its behavior and when its reliability might drop, the human um, uh, becomes better at interacting with that machine. But also the interaction between transparency and trust is of interest. Previous studies found that transparency increases human trust in machines. But also some other studies showed that increased trust results in high reliance rates, which brings the risk of over-reliance. That is, from one side, transparency was shown to be um, important for improving the interaction between a human and the machine. From the other side, transparency was found to increase trust, and increased trust was shown to result in high reliance rates. This raises the inquiry of whether transparency leads to better interaction or leads to undesirable over-reliance. We conducted a study to examine this question. We formulated two research hypotheses. The first hypothesis is that transparency positively impacts trust calibration. That is, that is, it improves the matching between trust and the actual capability of the swarm. The second hypothesis is that transparency also leads to proper reliance rather than undesirable over reliance of the swarm on the swarm. This means that our hypothesis means that um, uh, trust that is based on increased transparency have distinct implications on human behaviors. Our study considered a foraging task in which the swarm is deployed in a remote environment to search for and collect target objects. The swarm autonomously searches for targets. When the swarm finds an object, each member tries to classify it as a target or non-target. Then a voting mechanism is used to aggregate swarm opinions and make a recommendation to the human supervisor. The human can directly accept swarm's recommendation so that the swarm can um, uh, execute the corresponding action, that is, collect the object if it's classified as target or otherwise leave it. Alternatively, the human can request to verify the targets themselves before deciding an action. This means that the swarm would take an image of the object, send the image to the human, and then waits for the human to inspect the image and make a decision. This verification process is costly as it incurs communication overhead and inspection delays. We used a 2 by 2 factorial design with two transparent reliability conditions. Conditions with transparency. In these conditions, swarm recommendation was accompanied with information about the degree of agreement between swarm members. Meanwhile, conditions without transparency have only swarm recommendations with no other information accompanying um, uh, the recommendation. 32 subjects were recruited for the study. Each subject performed the task under all four conditions. We collected data about participants' trust in the swarm under all four conditions, and we also logged participants' behavioral data. Our results can be summarized in the following tables. We found that transparency led to increased trust in the swarm, which supports our first hypothesis. Transparency did not result in increased reliance rate, but it led to increased correct acceptance rates and increased correct rejection rates. That is, human became better able to interact with the swarm by accepting its recommendations when the recommendations are correct and um, rejecting its recommendations um, were um, uh, when they weren't correct. This is a complete um, um, set of the results, which I invite you to inspect by reading the paper. Findings from this experiment can be summarized as follows. First, increased trust always correlated with high reliance rates and short response times in all four conditions. That is, participants with high reliance rates with high trust levels showed high reliance rates and shorter response times than participants with lower reliance rates, with lower trust levels. Second, trust correlation with correct rejection rates differed based on how trust is formed. When trust was formed by increased swarm reliability, increased trust means less ability to reject incorrect recommendations. In contrast, when trust was formed by increased swarm transparency, high trust meant high or better ability to reject incorrect SWAP recommendations. The take-home message from this is that transparency is a necessary design requirement when humans are to be involved in the decision loop, especially when swarm reliability is high. These are the references I cited in this presentation. Thank you for your attention.